Hi. So very good morning to you all. I think you are all suffering a lot due to corona effect. ಸೊ ನಮಗೆ ನಿಮ್ಮ ಕ್ಲಾಸ್ಗಳನ್ನ ಜಾಸ್ತಿ ಕವರ್ ಮಾಡಲಿಕ್ಕೆ ಆಗ್ತಾಯಿಲ್ಲ, ಕಷ್ಟ ಆಗ್ತಾ ಇದೆ. ನಾವು ಸಾಧ್ಯವಾದಷ್ಟು ನಿಮಗೆ ಎಫರ್ಟ್ ಹಾಕ್ತೀವಿ. ಈಗ ಏನು ಕಳಿಸ್ತಾ ಇದ್ದೀನಿ ಅದೇ ರೀತಿ ವಿಡಿಯೋಗಳನ್ನ ಕಳಿಸ್ತೀವಿ. ಸೊ ಸಾಧ್ಯವಾದರೆ ಎಲ್ಲರೂ ಕಳಿಸ್ಕೊಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೀವಿ. ನಿಮಗೇನು ಕನ್ವಿನ್ಸ್ ಆಗಲಿಲ್ಲ ಅದನ್ನು ವಿತೌಟ್ ಹೆಸಿಟೇಷನ್ ನಮಗೆ ಮೆಸೇಜ್ ಮಾಡಿ, ನಾವು ಅದು ಮತ್ತೆ ಕನ್ವಿನ್ಸ್ ಮಾಡಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೀನಿ. ಸೊ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ಇಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಆ್ಯಸ್ ಯು ನೋ, I stopped with that example what you sent yesterday. In that continuation, so today we have one problem. Examine the nature of force free magnetic field B of x in rectangular coordinate system x, y, z. Okay, so we have to examine the nature of the force free magnetic field B of x in rectangular coordinate system x, y, z, and also the nature of abnormality parameter alpha. Let us see how to solve this problem. So please come to the page. Examine the nature of force free magnetic field B of x in the rectangular coordinate system x, y, z. So to solve this problem, let B is equal to bx, by, bz. You know, bx, by and bz are components of velocity, components of vector b. As you know, b is a function of x only. Therefore, these components bx, by and bz are functions of x alone. Now, to find the nature, you have to solve two equations. One is the continuity equation and other one is the basic equation of force free magnetic field. That is, so you can write the basic equation in this form also, because as you know, b cross b is equal to 0 means two vectors are parallel. Therefore you can write b as b is equal to some alpha into b. In that manner, so we can write this equation in this form. Now from equation 1, del dot b is equal to 0. You know how to expand this equation, because del means del by del x into I plus del by del y into j plus del by del z into k. Dot b means bx into I, by into j, bz into z. Bz into k. By expanding that means by taking the dot product, you are going to get only one term bx by x, because it is function of only x. That's why with respect to all other variables will become 0. So this is the partial derivative, but only one independent variable. That's why you can write it as an ordinary derivative. Therefore dbx by dx is equal to 0. It means that so bx should be a constant. I am going to take that constant as some c. Right. Now consider this equation. To consider this equation, you must find del cross b. So del cross b is equal to, as you know, determinant of these, the components of the derivative and the components of the vector, means differential operator as well as the vector components. By expanding this, you are going to get this equation. But in this equation, this is with respect to y, this is with respect to z, this is with respect to z, and this is with respect to z. Y. These all terms will get cancelled, means will become 0, because they are functions of x only. That's why the remaining terms are minus j into del bz by del x plus k into del by by del x. So now consider the full equation, this one, del cross b cross b. Now you found already what is del cross b, you know what is b. That's why del cross b is equal to determinant of this one, I, j, k. The components of del cross b are these and the components of b are these. Right. By expanding this, you are going to get I into something, j into something, k into something. I am not going to read all those things, because you know how to expand the equation. Right. Now the given equation is del cross B is equal to 0. Means that equation should be equated to 0. That's why whatever the expansion obtained from the determinant must be equal to 0. Now by equating the components of I, you are going to get this equation. By equating the components of j, you are going to get this equation. By equating the components of k, you are going to get this equation. But you know already Bx is equal to C obtained from the continuity equation. You obtained from the continuity equation that so Bx is equal to constant C. That's why by substituting that here and here, here and here, you are going to get so these two equations, and this equation can be written as a total derivative in this form, because by differentiating you are going to get the same equation. That's why this equation can be written in this form. Now from these two equations 6 and 7, so you have two situations. One is either C must not be equal to 0 or C must be equal to 0. If C is not equals to 0, then equation 6 and 7, from these two equations you can get either dby by dx is equal to 0 or dbz by dx is equal to 0. So it shows that by and bz are constants. Do you agree? Because the derivatives are 0 means must be by and bz so equal to they must be constants. Therefore, already you obtained that Bx is equal to constant. So now you got By is constant, Bz is constants. All three components are all three components are constants. That's why the vector magnetic field must be a constant vector. But this will be the trivial solution. Is it right? So that's why this is not the suitable case. Now go for the another case, that is, so if C is equal to 0, then what happens? If C is equal to 0, then we have to go for the equation 5. From equation 5 you can get, so after upon integration you are going to get by square plus bz square is equal to a constant. Is it right? So I am going to put that constant as some b0 square, right? This equation is also valid by taking the substitution by is equal to b0 into sin theta and bz is equal to b0 into cos theta. Look here, by substituting by is equal to b0 sin theta here and bz is equal to b0 cos theta here, you are going to get b0 square, because sin square theta plus cos square theta is equal to 1. So where theta is an arbitrary function of a magnetic field is a constant for all x, and this shows the nature of the magnetic field. Okay. Now to find the nature of the abnormality parameter alpha, so we have to use this equation again. But already you know what is del cross B from the previous section. Now, so you see that Bx is equal to 0, because so we have considered the situation, means case when C is equal to 0. But you know that Bx is equal to C. That's why Bx must be equal to C and By. For that case, By is obtained as B0 into sin theta, Bz is obtained as B0 into cos theta. Now consider del cross B. So by substituting, this is the differential operator, the components of the differential operator, and these are the components of the magnetic field. By expanding this determinant, you are going to get this equation. In both the equations, d theta by node here, look here, I into derivative with respect to y 0, derivative with respect to z 0, because they are functions of only x. Now come to minus j into, I have not taken minus here because it is going to be plus after multiplying with this one. That's why j into, look here, j into derivative with respect to x, that is nothing but derivative of cos theta is minus sin theta into d theta by dx. Thus that minus and this minus will get cancelled and this will become plus sign. Similarly when k, so derivative with respect to x means derivative of sin theta is cos theta into d theta by dx. By taking d theta by dx common, you are going to get this equation. Now, but this is nothing but your b, vector b, because the components you know bx, by, bz, bx, by, bz. That's why this is nothing but your vector b. But we know del cross b is equal to alpha b. So now you obtain that del cross b is equal to b into del theta by del x, and this is nothing but your alpha into b. By removing vector b on both sides, because this is a non-zero vector, right? That's why by removing the vector b on both sides, you are going to get alpha is equal to d theta by dx. It means that alpha must be a function of x. Already you know that. So alpha must be either purely a constant, or it must be a function of position as well as position as well as time. Here you got that alpha is a function of x, means it's a function of position. Obviously it must be a function of time also by virtue of its property. Therefore it must be a function of both position and times, right? So I put this effort in this manner for you. So if you understand neatly, then there will be no problem. If you want any improvement here, so please ask me without any hesitation. Thank you. All the best.